Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck. Today we're going to be learning about graphing linear functions. This is going to be our first episode in graphing linear functions. So if you are new at graphing or linear or anything like that, this is going to be the place that you want to start. Speaking of places to start, let's get started. So what I have right here is a linear function. Notice the function notation that I'm using. That's from our previous episodes on functions. If you haven't watched those and you'd like to understand the relationship between two variables that we call a function, and you don't really know what that means or you haven't seen this, go ahead and watch those right now. I'm not sure where the link is, but hey, you can find it. Here's the link to one of those videos. You can get started there. For our purposes today, even though we're going to be talking about linear functions, I'm actually not going to use this notation. If you remember from those videos, the function of x, or f of x, really all it means is y. And what we're going to use today is the variable y. The reason we're doing that is because we're going to be graphing them, and the graph has an x and y axis. And I think this does a better job of explaining that idea. So let's jump in here. So when I'm looking at a function, the first thing that might jump out to you is the fact that there's two variables here. Most of the other problems that you've done in algebra, they're one variable. You solve it, it's one number, and you're done with it. This kind of problem, there's two variables, and you can't really figure out what number each variable is. In fact, the variable y doesn't even really have a meaning until we know what the x is. So once you know what number x is, then you can find y, or if you know what y is, you can find x, but neither one of them has meaning apart from each other in this equation. Let me show you what I mean. I can put any number I want in for x, and it changes the value for y. So I could plug in, for example, I could put in 2. 2 times 2 is 4, minus 3. That's just a positive 1. So when I put a 2 in for x, I get a different number for y. Now I could put any number I want in for x, actually. I can put in negative numbers, I can put in positive numbers, I can put in decimals. Anything that I want, I can put in here. And I can see that what I put in for x changes the value for y. So saying what number one of these is, it doesn't actually mean anything. The important thing that I want to be looking at is the relationship between x and y. Since they don't have meaning apart from each other, their relationship is what's important. Now, the relationship can be represented in a number of different ways. I can represent it with an equation. And as you saw with those numbers I was just putting up there, every time you have an x, you multiply it by 2 and subtract 3 to find y. That's one way of representing it. That's what the equation tells us. But there's actually other ways of representing the relationship between x and y in this linear equation. You can also represent them with a table. So remember, I can put in whatever numbers I want in for x, and that changes the numbers for y. I can represent a combination of those numbers here. Now I'm going to pick just some random numbers for x, and I'm going to choose to go up by 1 each time. So I plug in negative 2. If I plugged in negative 2 in here, 2 times negative 2 is negative 4. Minus 3 is negative 7. And I can see that there's a relationship between these two variables. What I'm going to do is I'm going to choose to go up by 1 each time for x. So up 1 on the number line is negative 1. Negative 1 times 2 is negative 2, minus 3 is negative 5. And what you see here is that this is another way of visualizing how this relationship between x and y works. You can use a lot of examples here. And what you might start to see are some patterns that emerge in what's going on here. And you can start to see how these change over time. Because again, the important thing here isn't the specific number that x and y is, it's the relationship between them. So let's see if we can find some patterns here and see if that tells us a little bit more about how these functions work. Now again, I told you from the beginning that I chose to add 1 to x each time. So this is a nice, easy relationship to find. But I'm going to write it down anyway. Every single time I put another number in for x, I've added 1 to it. And it's nice to have a consistent pattern there for your x's since you get to choose those. Now down here, because I've chosen a pattern for x, I can see if there's any resulting pattern for y. And the distance between -7 and 5, that's +2. And if you look here, the distance between each of these is 2. I've added 2 every time between these different numbers. In fact, all of these, I've added 2. Every time I go up by 1 on x, I go up by 2 for y. This idea of adding the same number each time is actually one of the characteristics of a linear function. Every linear function, you will add the same number each time. You can even add negative numbers, which looks like you're subtracting the same number each time. But regardless, it's always the same thing, either adding or subtracting. If you see that in a function, that is what makes it a linear function. We can also see some connections between the table and the equation. Some of you might have seen already that there's a 2 down here and that there's a 2 in the equation. There's a 2 in the equation. That's not a coincidence. These are the same exact number. And it's a little harder to find the 1 in here, but it's also in that same idea. It's in the equation. Instead of it being just a 2, it's actually a 2 divided by 1. So this 1 goes here, and this 2 is right there. The 3 shows up as well in the equation, the -3 that is. If you want to look for the -3, you try to find the place where x is 0. I see here, this -3 is that exact same -3 there. Now these patterns show up consistently across all linear functions. They're so consistent that we've written a general formula for linear equations. Now most textbooks will have your equation looks like this, y equals mx plus b. Some choose to use ax plus b, it means the same thing. The m comes from the pattern. So notice here, the 2 was the 2 number here. This is that number in front of x. It's always going to be the pattern. Your teachers might give you some different names for that we'll talk about later in the video. But for right now, I want you to think about this as the pattern. It's the pattern that you see in your linear function. This number over here, b, represents the 0 term. It's the number that you get when you put in 0 for x. So I like to call this the 0 term. Again, there are some other names we'll talk about later in the video, but if you understand this as a pattern and this as the 0 term, you really start to internalize how these linear functions work, and it'll make a lot more sense in all the other things that you're doing. So we've talked about the equation and the connection with the table, but there's actually a third way that we can represent linear functions. Because we have an x and a y variable here, we can also represent them with a graph. So let's see what this looks like if we were to plot some of these points on your graph, and we'll see what happens and if we can see any more connections between those. When you're beginning to graph equations, I think the easiest way to start is to actually make a table. It's never a bad idea to make a table when you're looking at an equation. And always pick at least one negative number and 0 when you're picking points. Because graphs don't just magically stop when x is 0, they can be positive or negative in most cases. So let's go ahead and plot these points. And I want to see if we can find, again, some more connections. We saw that the pattern showed up in the y values, that it was adding 2 each time. And we saw the 0 term showed up when x was 0. Let's see if we can see any further connections with the actual graph. Now I've plotted the points here, and you can see there's just a bunch of dots. Now many of you, if you were doing this at home, probably would connect them, but you should always ask yourself whether you should connect those dots or not. And it's not as simple as just if there's a pattern, you should connect them. The reason we connect the dots, actually, is because there's all these numbers in between here. I arbitrarily chose to increase my x by 1, but there's no reason that I couldn't have chosen 1.5 in here. and seeing what I would get. And what would happen is, if I put in all these points, maybe I put in 1.6, and that would give me 0.2. And you'd end up with a bunch more points. And what happens is, if you actually put all the decimal points in, you end up with this line of dots. The line of dots we represent with a line, because it's a lot easier to draw a line than an infinite number of dots. So I'm not going to ask you to draw an infinite number of dots. Just connect them. But you should always ask yourself, in many cases you don't connect the dots. So ask yourself if these decimal points are in between. Can you plug them into your equation and get an answer? If the answer is yes, then you can, and we call this a continuous graph. If you can't connect the dots, we say it's a discrete graph. So here's my graph, and I want to see if I can find any further connections. So I notice, again, that there's a -3 on this graph, and it's right here. The 0 term shows up, and it's the place that that line intersects the y-axis. Now, what many of your teachers have probably told you that this is that this is the y-intercept. And that's what we call it generally. But the y-intercept comes because x equals 0, and we plug that into our equation. So be careful to understand that you can find the y-intercept just as easily by looking at the table as you can the equation or the graph. All three of those things mean the same idea. The next thing that we saw in our equation was the number 2, and remember, I was very specific. I said that it was actually 2 over 1. This is actually a little harder to see on the graph. I don't see any place that it necessarily touches 2. You have to be a little bit more clever about how you look at it. But I want to pick any two of these points. And I can see here, maybe I'll pick this one, 3, 3, and 4, 5. And I'm going to look at the distance between those two. I'm going to measure the distance between 3 and 4, and I'm going to measure the distance between 3 and 5. Now, if we look at this here, I see that this distance is 2. You seeing what I'm going with here? And the distance here is 1. And I've made a little triangle here to show that I've actually got that same number, 2 over 1. Typically what your teachers will call this, because this number right here, what your teachers will call this is they call it the slope. The reason they call it the slope is that it represents how steep your line is. The bigger this number is, the steeper up it goes. So we call it a slope, like you might think on a mountain. So the slope of this line is this number right here, and it represents the pattern in the table. So that's what we're looking for here, and that's the connection between all of this. So once you get good at this, you start to recognize that you actually don't need to make the table. You can go directly from the equation. When you get an equation, you can immediately plot the 0 term, which is the y-intercept. You can put a point right there. And then, if you're careful, you can directly graph from the slope. You know that your x number here is 1 because it's over 1, and then you can graph up 2. And you can go over 1 and up 2 and continue to draw your next points. And once you have enough points, you can connect your line because this is a continuous equation. As a side note, there's an equation for the slope that you can look at as well. Notice I made this a fraction. The equation that many teachers will talk about for the slope, or m, is this. We say it's the change in y over the change in x. Remember when we looked at our pattern before, we looked at the change in y and the change in x. If you look at those two things, you'll see the slope. One of the ways it's abbreviated in many textbooks is this triangle. The triangle is the Greek letter delta, and whenever you see delta in math, it stands for the change in. So if you see delta y over delta x, that means the change in y over change in x. Let's do one more example, and I'll give you a few more tips to make sure that you can get this right. All right, let's look at this other example here. Notice on this one, I've got a negative and a fraction here, so we're getting quite a bit more challenging. Let's go ahead and plug in some numbers for this. Again, remember, we're going to take a look at our table first. Once you get a little better, you won't need to do the table first, but let's see what happens. So I put in -1 here. Always at least do one negative. And when I plug -1 in, I actually end up with a positive 5/3. That's the same as 1 and 2/3, but you're in Algebra 1, you don't need to use the middle school and elementary school version of mixed numbers anymore. I can put 0 in, and I get 1, and I can fill in the rest of these numbers here. Now, for some of you who are afraid of fractions, you can see why it might be nice to not have to do a table. Because it's harder to see the pattern here. And if we look, we see that the pattern is I'm decreasing by -2/3 each time. I'm subtracting 2/3 each time from this. But there's another way to think about this pattern. I could skip some numbers, maybe get some whole numbers here. And if we look, every third number is a whole number for both x and y. Let's see if we can see what the pattern looks like there. So between 1 and -1, I decreased my y by 2. I've subtracted 2. And between those same two numbers for x, I've added 3. Let's see if that happens again. Between 1 and -3, I subtract 2 again. And between 3 and 6, I added 3 again. So if we look at our pattern, the change in y over the change in x, I see that it's a -2/3, which is the pattern here. So that pattern still does show up. The cool thing about it, if it's a fraction, is you can skip all of these numbers in between. They're not that important. You can pick the whole numbers that are easier to graph and easier to do the math on. Let's go ahead and start with our 0 term and plot a point. And then I'll just plot all these. You don't have to listen to this. So I plotted 3 points here, just the whole numbers. But again, you can see that I've got the fractions in between. So that means I can connect all of my dots, and I can have a continuous line again. A couple of things I want you to notice here. This line seems to be going down as I graphed it left to right. That pattern shows up in the negative in your slope or pattern. The 0 term is still a y-intercept. It's still 1. That's really easy. Now let's see what happens here if we can see that slope again with a triangle. If I pick these 2 points here, I need to go down 2 to get to the next one and over 3. So once again, you see a really nice triangle that shows you how that pattern and slope work. One quick trick to see if you're graphing your slope correctly or not. If your slope, is to write your name on top of it. So I always tell my students to do this. Write your name on top. So I might say, write my name, Mr. Calbeck. Notice when I write my name on top of the line, it's going down. If your name goes down, you should have a negative slope. Those things should match. If your name goes down, negative slope. If your name is going up as you write it, you should have a positive slope. So it's a really easy way to check your work as you're going along. My students love to troll me on tests by writing all sorts of different names for me that are maybe a little less nice than Mr. Awesome. But it's a fantastic way to check to see if you are graphing your lines correctly. Okay, so in review, functions, no matter what they are, can be represented easily in 3 different ways. We can represent them as an equation, a table, or a graph. All 3 connect. Okay,
Hey guys, thanks for watching. I hope this was a helpful intro for you to learn about lines and graphing and how everything all connects together. If you enjoyed this video, please subscribe and let me know in the comments what other videos I can do to help you guys learn math better. Good luck with everybody out there doing remote learning and everything else. It's super challenging, but hopefully these videos can help make this tough subject to learn on your own a little bit easier. So I'll see you guys next time.